Okay, hello everyone. Yeah, so that would be the second episode of me learning C++ threads. And yesterday we left off, actually, let me see. Yeah, I implemented the thread protection structure, which basically helps to, for example, we already know that, for example, when we create a thread and execute a thread, it has to be either joined or detached. If you don't do neither of those, if you take a look at the structure of the thread, it checks whether the thread is joinable, and if it is, it terminates. So make sure you join the thread or you detach it. So yeah, that's what we covered yesterday, and today I'm planning to continue, and as usual I will be following the book C++ Concurrency in Action. Okay, so let's just continue programming. Let's continue learning about threads. Okay, that's the direct text. Let me find the actual one, the book that we will be using today. Okay, so we were talking about how to run threads in the background, that you have to implement, that you have to call the detach function instead of join, and yeah, okay, basically we assert here that the thread is not joinable, which is correct, because we executed the detach function, which means that we will not be waiting for the thread to finish. Okay, but let's continue. In order to detach the thread from a cthread object, there must be a thread to detach. You cannot call detach on the cthread object with no associated thread of the execution. This is exactly the same requirement for join. You cannot join twice. That's reasonable. Okay, so here is some example application. That's not really interesting. Yeah, I want to acquire some more general knowledge about threads, and I want to jump straight into implementing like data structures, concurrent data structures like queues and stacks and vectors using threads. That's why actually reading this book, and the goal of the series is just to be able to implement data structures using threading and familiarize myself with threads, pools and things like that. But I have to start from the beginning in order to make sure that I don't skip anything, like any imperial information. So passing arguments to a thread function. Passing arguments to the callable object or function is fundamentally as simple as passing additional arguments to the thread constructor, but it is important to bear in mind that by default the arguments are copied into the internal storage. As we've talked about yesterday, we already know that by default, and I'm not actually sure what it means, like by default, can we configure it somehow? Not sure really. By default, all the data are copied. That's correct. Into the internal storage of the thread, where they can be accessed by the newly created thread of execution, even if the corresponding parameter in the function is expecting a reference. Here is a simple example. Okay, so the function takes a reference to a string, it's a const reference, and then we create the thread, and this creates a new thread of execution associated with T, which calls f. Yeah, makes sense. Okay, so let's create it. Let's create a new thread, and probably we'll need a lambda function. Would be easier. Procedure. And we know that we have some arguments, so we'll have to pass them as well. So the first one is std string, right? And that's a string that we are passing, and we were considering passing some number as well. Okay. So let's pass the number. Right, and the author is trying to pass like the buffer. Try. Okay, so they okay, makes sense to me. So what we're doing here is we're detaching the thread, meaning that we leave the thread to be executed on the background, and but we pass into the function, to this function, the local reference to the local variable. It's like the same idea as when you are trying to return a pointer from, as you are trying to return like a pointer to the local variable inside a function, or a reference to the local variable which were created on the stack of the function scope. So you will get the same kind of behavior which will be undefined. We can try doing that, so we will do something here, and we can create a buffer. Let's highlight that it's like a local thing, local buffer. Let's create like a 4 kilobytes buffer, and then we can pass some kind of a variable, and the procedure itself should be the first argument that we pass to the thread constructor, and the local buffer. The constructor for the std string will be invoked, and we will convert from the char array to std string. But then what we have to do, if we execute right now, we'll see that we will terminate, because the thread is joinable, which means we didn't call explicitly join. We would either have to do it here, or we have to use like a thread protection from the previous episode when I implemented like this structure which checks whether the thread is joinable, and if it's not, and if it is, you just join the thread. But here what we are trying, what I will try to do is just detach to make sure that the thread is running in the background. Don't wait for the thread to finish. And that might be the problem, because for example, if we get out of the scope, or go out of the scope, so for example here, and the thread still continues an execution, or I can make it like this, even more explicit. The new thread is still continues the execution, and which means that the thread operates on the local variable which went out of the scope, which means that it no longer exists. And there might be some problems with that. In this case, it's the pointer to the local variable buffer that's passed through to the new thread, and there is a significant chance that the function oops will exit before the buffer has been converted to a std string. On the new thread, that's leading to undefined behavior. Yeah. Undefined behavior. The solution is to cast to std string before passing the buffer to the std thread constructor. So it will be copied to the internal storage, because right now we just copying the address, I think, but I'm not sure. The pointer to the local variable that's passed through to the new thread. Okay. Std thread, we have to cast to the std string. So basically what we are doing is we're creating like a temporary string. In this case, the problem is that you were relying on the implicit conversion of the pointer to the buffer into the std string object expected as a function parameter, because std thread constructor copies the supplied value as is without converting to the expected argument type. Oh, right. So now I understand. So basically how std thread operates is just takes this buffer and it doesn't it says that there is no implicit conversion. It doesn't convert the pointer to the buffer to std string object like directly. It just copies it into the internal storage, and then I assume from the internal storage it will copy. So doesn't convert implicitly to std string, doesn't convert pointer to buffer to std string, where the copies it into the internal storage first. So that's what it does, I assume. That's how I understand it, at least. In this case, the problem is that you were relying on the implicit conversion of the pointer to the buffer into the std string object expected as a function parameter, because std thread constructor copies the supplied values as is without converting to the expected argument type. And that's very important, actually. Std thread copies all the arguments to its internal stack without conversion. For example, from char I don't know how many characters to std string, right? Like this. 96. Or wait a second. No. I don't remember the syntaxes of passing like arrays to functions, but I think that's correct. We can try. So for example, void function takes an array to now that's not correct. Okay, so that's the correct syntaxes. That's the correct syntaxes, and we can do whatever we want. We can print the first element, and we can, oops, forgive me, we can print the second, the third, and the fourth element. And what we can do as well, function takes an array, and here is an array of size 4. A, B, C, and D, right? That's okay, and then when we execute the function, it will print all the letters that we specified without any problem. That's fine. I just want to show you how to pass like how to take, but nobody does this way. Everyone, like, it's much more convenient to expect just a pointer array or a pointer. But since we are using C++, it's better to like stick with std string. But char pointers are pretty convenient. I don't know why people hate them, and row pointers in general. So let's see, and here is our ABCD. Everything's correct. So let me remove that function, and let's continue. It is also possible to get the reverse scenario, and the object is copied, and what you wanted was a reference. And what you wanted was the reference. This might happen if the thread is updating a data structure that's passed in by a reference, for example. For example, this. To get the reverse scenario, the object is copied, and what you wanted was a reference. This might happen if the thread is updating a data structure that's passed in by reference, for example. I'm not sure that I'm getting, but what I will try to do is create like a widget, widget data, okay? Widget data, okay, yeah, sounds fine. Widget ID. Okay, so we're trying to, so this function, okay, yeah, makes sense. So we passed like the, but we are copying here. And we have a data, but the function that we are executing on this thread expects a reference. And we are passing a reference. The data that we created on the on the stack, and we pass a widget ID to the function. Okay. Now I get it. Update widget. So let's assume the following situation, that we have like a function, and let me make it. I don't really need to make it static, which takes the widget ID, right? Widget, and well, I don't know. Widget ID, data. Create the constructor and widget. Now let's not gonna do that. Let's stick with the simplest solution possible. And then we have std thread, new thread. Update widget data. Update widget data, and what we can pass is widget ID and widget data, right? widget ID. There is no reason because the struct is very small. It's extremely small. It has only one member. But yeah, just for learning purposes, I will pass both widget ID and widget data. No, not actually both. I will pass widget ID by value and widget data by reference. Widget data and do something with the widget data. Probably what we can do is update the new ID. New ID ID equals new ID. It's not really a data. I don't know what else we can have. For example, like a color of the widget, or is toggled. For example, a boolean. We can specify a boolean, for example, is toggled. And I will put it above so I can use it almost everywhere. I know, actually I don't like using the bool because it's 8-bit and it's not aligned by neither 64 nor 32-bit boundaries, so that's why I prefer using bool 32 instead. So we have to check whether it's toggle or not, and if, for example, if it is widget data is not toggled, then we toggle the widget equals true. I don't know, some simple logic that we can utilize. And here what we do is we pass the function to the thread so it can be called on a separate thread. And what else we pass here is the widget ID. It's not really okay. Can be yeah. Widget. That's fine, and the third parameter would be data. And we try to detach the thread and let it run. Detach. So let's see. Okay, so basically in this example we join the thread and we process the widget data. Expect the second parameter to be passed by reference. Constructor doesn't know that. It is obvious to the types of the arguments expected by the function, and blindly copies the supplied values. Okay, so it just copied the value into the internal stack. Use the widget data. So at this point of code is expected to be updated already on a separate thread, or I would put it this way, by a separate thread. But it will not, because it will copy by value. Let's see, and I'm not calling that function anywhere, but here is the error message, and I'm not sure what it's saying. Okay, since this is instantiated at compile time, the thread creation, the error pops up at compile time as well. I think the main reason for that is because we pass in a reference, And when this book was written, probably a long time ago, the C++ standard allowed to pass, to expect the reference and to pass basically an argument, but then the thread itself copied everything into its internal storage, and we didn't have any error. Because what I will do is, for example, let's assume that I pass in const here, and I will comment that out and see if it fails or not. And everything works correctly because I'm passing like a const reference, which means that I won't be modifying the value. But in our situation, we want to modify, we want to update the widget ID, right? And the workaround for that is to do it like this. Don't ask me how it works. I didn't get to the point where so basically the ID will be updated at this point. Let's call this function. Let's call this function and widget ID equals, I don't know, let's assign 3, and then we call the ID, we pass it by value, and I will show you in a second that if data ID equals 3, then debug break, right? Because we expect this to be 3. Well, okay, ID. It's a little bit confusing, but I hope you got an idea. I will put a breakpoint here. Okay, so we created the widget data, and let me pass the data in the watch window so you can see. Right now it's like some rubbish, and probably I should have created the constructor so we can initialize to 0 by default, or we can even do this. So here is our ID is 0 and toggle is false, and I will put a breakpoint in this function as well. So we create a thread, and as you probably have noticed, if you didn't, I can run it again. So when we create a thread, we add an additional thread to the threads pool in display window. Okay, so just jump to the thread and start executing the procedure. Okay, and we hit a breakpoint, and as you can see, the ID was updated successfully. And I don't know how it works, to be honest. Like when you use std reference, I can Google, but I will not promise it. I don't know, you probably have to try to figure out it on your own how std reference works. Probably wraps somehow the data. So we can take a look at the implementation. Reference wrapper. So that's what it. Okay, so that's a reference wrapper. Ref the value and the reference wrapper. So that's the class. That's a move constructor. I just want to find like the regular constructor. Yeah, because I'm confused a little bit. Because the author says that everything passed to the thread is copied into the internal storage, but I know that we saw that it modified the value, and like the data ID would be, the widget ID would be 3, and the status will be toggled. The widget will be toggled. So yeah, let's just step inside. So we invoke in this constructor, we pass in a reference, and what we do is we return an instance of reference wrapper. And what it does is object, is function. So it either has to be an object or it has to be a function. So we create a different type, and conjunction is basically when so std conjunction is basically, or disjunction, I don't exactly remember, but I think like conjunction says, so given two sets, make sure that they have some, either they don't have any elements in common or they have an element in common. I don't exactly remember. But we don't have like a default. Okay, so that's just a pointer to the type. So it has a pointer. Also, maybe that's the reason. Because it copies like the address into the internal storage, and then it modifies the contents, whatever is in that memory, and that's why we have we can see the effect, right? I hope so. But let's continue. The second parameter to be passed by reference, the std thread constructor doesn't know that. It is obvious to the types of the arguments expected by the function and blindly copies the supplied values. Well, when it calls update data for widget, it will end up passing a reference to the internal copy of data and not a reference to data itself. Consequently, when the thread finishes, these updates will be discarded as the internal copies of the supplied arguments are destroyed, and we will not see any changes. Okay. Will be passed an unchanged data rather than the correctly updated version. For those of you familiar with bind, this solution will be readily apparent. You need to wrap the argument that really need to be references in std reference. In this case, if you change the thread invocation to std reference data, then the update data for the widget will be correctly passed a reference to data rather than a reference to a copy of data. I have no idea how it works under the hood, but it does work in general. And we saw that we managed to update the data, the ID of the widget, and either it's toggled or not, set the toggle member to true. Will be correctly passed rather than the reference to a copy of data. If you're familiar with OK, we done that. This means that, for example, you can pass a member function pointer as a function provided provided you supply a suitable object pointer as the first argument. I don't see what the relationship is std bind, std reference, and right now he's talking about that we can pass like the member function pointer to the member function and the object, and we've done it yesterday. it's possible. You just have to, since the member function accepts the first implicit parameter that is a pointer to the object of the class, which is this, right? We'll have to pass like both of those, the function and an object. Okay. Transferring an ownership of threads. Yeah, that's, let me take a look. For supplying arguments is where the arguments can be copied but can only be moved. The data held within one object is transferred over to another, leaving the original object empty. An example of such type is std Nokia pointer, which provides automatic memory management for dynamically allocated objects. Only one std pointer instance can point to a given object at a time, and when that instance is destroyed, the pointed to object is deleted. The move constructor and move assignment operator allows the ownership of an object to be transferred around between std Nokia pointer instance. Yes, that's correct. Such as transfer leaves the source object with the null pointer. Okay, so basically what it says is if you create like multiple std Nokia pointer instances, and I'm not sure whether I have like the header file for the Nokia pointer. Memory. Okay. Let's just create a Nokia pointer to integer and iter2 pointer. And let's specify like 10 elements, right? 10 elements, and then we iterate for index equals 0 plus plus index index less than 10. Yeah, I don't want to specify any sizes. I just want to fill the data pointer. Okay, plus index, and then the reference. I'm not really sure why it doesn't work, because okay, that's a unique pointer. Get the data pointer oops, and let's try index. Let's see what happens. Yeah, everything's correct, and let me take a look at the this pointer, and we have a pointer. We don't have any data. Why? It's because that's a pointer, right? Okay, that's exactly what I expected to see. Yeah, okay, so with the index 0 we have 0, 1, 1, 2, and etc. So that's correct. Yeah, but what we want to do is let's just reduce the amount of integers to a single one, and I will grab like a unique pointer, and I will say okay. Another pointer, and what I can do is I will just assign, right? Okay, so I can move. Invalid type expression. I wonder what... Okay. Yeah, just give me a second. It's called the remove reference. Static cast remove reference. And what does it do? It just get the type. Okay, basically what I want to see is to make sure that this equals to 0 after we moved the contents. Okay, and it is. So let's continue. I'll delete that, which provides automatic memory management for dynamic allocated objects. Only std unique pointer instances can point to the given object at the time. The move constructor and move assignment operator allow the ownership of an object to be transferred around between std unique pointer instances. Such a transfer leaves a source with null. This moving of values allows object of this type to be accepted as function parameters or return from the function. Where the source object is a temporary, the move is automatic, but where the source is a named value, the transfer must be requested directly by invoking std move. The following example shows the use of std move to transfer ownership of a dynamic object into the thread. Okay, so in order, we have a pointer here, and we create a thread, and we transfer the ownership to the internal stack of the thread. Pointer std thread new. Okay, let's just mark it T for simplicity. It doesn't really matter. T proc sounds good to me. Much more simpler, less time consuming. And what it does is just takes an std unique pointer to int and pointer let's not gonna do std move first. and see what happens. Well, there's quite a lot of errors, and everything is in compile time. The reference of a function, blah blah blah. And everything comes from the memory file. So there are definitely a lot of issues with Unique pointer. If we pass it like this, what we have to do is to move. Okay. And right now everything works correctly. All right. All right. Okay. Okay. Yeah. That's the mistake I made. Pointer will be null at this point because we moved the thing that a unique pointer points to, right? It's a unique pointer. It cannot, the memory cannot be shared. And what I did is I tried to dereference the null pointer in this situation. We assigned the value to the variable that is in the internal storage of the thread itself, not this one, right? Because we moved the contents. And I'm wondering why I couldn't just static cast to add value reference. That's exactly what std_move does, but for some reason I couldn't do that. I don't know actually why, but static cast. Let's see. Can I do this? No, I don't. Okay. What about? Do we have like a full struct? No, we don't. Okay. How much time do I have left? Not much. And I don't really have any progress. That's how it is. By specifying std_move, std thread constructor, the ownership of the big object is transferred. In our case, it's not really a big object by any stretch of imagination, but just an integer, 32-bit integer. First internal storage of the newly created thread, and then in the process big object function. Right, makes sense. Several of the classes exhibit the same ownership semantic, unique pointer and std thread, which means that we can move the std thread itself to a different instance of the thread. This ownership can be transferred between instances because instances of std thread are movable, even though they are not copyable. This ensures that only one object is associated with a particular thread of execution at any one time, while allowing programmers the option of transferring that ownership between objects. So what it says is that, okay, I can create a different thread. T0, for example, and I can move. Can I assign T? No, I cannot, but I can move, and I hope it will invoke move constructor here. And then I have to call join on the thread 0. But let's put a breakpoint and see what happens. Okay, and we invoke in the Yeah, unfortunately I couldn't step inside, but let's take a look. So we have a constructor here, and we have some private members as well, and here we have public members. Can I just modify a little bit here? Okay, it doesn't really matter, but what I want to see, cout moving the thread. Okay, and operator equals, because I'm not sure what exactly I'm calling. And as you can see, like the copy constructor and copy assignment operators are deleted, which means that we not copy the we cannot like copy the object and the instance of std thread, and we cannot assign the object of std thread type. Okay, I don't see anything. So probably it was like a move assignment operator involved. And can I really put a breakpoint? Okay. Moving the thread. And thread operator to make sure that it actually the move assignment that's interesting. I thought we will call or we will hit a breakpoint, but we didn't. Okay, I assume I cannot modify like the standard C++ standard library because I don't see any changes for some reason. Maybe if I recompile it, probably, but I won't be able to recompile it, I think. I think I just compiled it once, and but that's a header file now. I don't know. I don't know why I cannot do that. But anyway, I just move in the ownership to a different instance. Transferring ownership of a thread. Suppose you want to write a function that creates a thread to run in the background, but passes back ownership of the new thread to the calling function rather than waiting for it to be completed. Or maybe you want to do the reverse, create a thread and pass ownership in some function that should wait for it to be complete. In either case, you need to transfer ownership from one place to another. This is where the move support of std thread comes in. Many resource handling types in the C++ standard library, such as ifstream, pointer, movable but not copyable, is one of them. This means that the ownership of a particular thread of execution can be moved between std thread instances, as in the following example. So we have a couple of functions. We move to a different thread here. And what else do we do? Okay, so that's where we invoke like the assignment, right? No, yes, okay, so that's where we invoke the move assignment operator. That's where we invoke move constructor, I suppose, but I'm not sure. First, a new thread is started. Let's just experiment, right? Just write code. So we have like the first function and second function. Okay, so we created a couple of lambdas. That will be enough. How about time? Yeah, have like a couple of minutes. And then I will create a thread. So that would be T0. And for the function that I want to specify is this one. Right? That's correct. And then I move. So at the end I will have to join only. Well, that's interesting. Yeah, basically I don't fully understand what's happening here. We're moving a lot, like the ownership, and I don't see the join method, and I don't see the touch method either. But there is like a command. This assignment will terminate the program. So let's just do everything exactly like it is here and see what happens. So we have like a thread 0, and then we create one more thread, T1, and then we move the ownership from T0. Can I use my static cast? Oh no, please. I want to use a static cast. Yes, finally. I don't know why it didn't work with like raw types, like integers, chars, etc. But with a thread, it works fine. And by the way, this is exactly what stdmove does, in just a cast to a value reference. But anyway, move the ownership. Ownership. Not sure whether I spell it correctly. Yes, okay. Std thread some other function. So, and then what we do, we create another thread, T0, and we use, like, we invoke the move assignment operator. I hope, and we pass like the second function, and then we create one more thread. First, a new thread is started and associated with T1, in our case it's T0. Ownership is then transferred over to T2 when T2 is constructed by invoking stdmove to explicitly move ownership. At this point, T1 no longer has an associated thread of execution. The thread running some function is now associated with T2. Okay. Then a new thread is started and associated with a temporary std thread object. The subsequent transfer of ownership into T1 doesn't require a call to stdmove to explicitly move ownership, because the owner is a temporary object. Moving from temporaries is automatic and implicit. Okay, so we don't need to invoke move constructor here. Don't need to std move for temporaries. The subsequent transfer of ownership into T1 doesn't require a call to std move, although I don't understand fully why. They explicitly move ownership because the owner, the T1, is a temporary object. Oh, you mean it's like in a temporary state because the contents was moved. Moving from temporaries is automatic. Okay, he's talking about this temporary object. Std thread, when we create like the thread here, so that's the temporary. Don't need std move for temporaries. Std thread creates a temporary variable, and that's why we don't need to invoke std move. I think so. Right, because it's R value. It's R value, right? We don't need to move. We don't need to invoke std move. Is default constructed? T3 is default constructed. Okay, let's do that. Let's do that and see what happens. So we default construct T3. Which means that it is created without any associated thread of execution. Yeah, I will write it down. Created without any associated thread execution. Ownership of the thread currently associated with T2 is transferred into T3. Then we transfer from T2 and then from T3 back to T1. Okay, that's crazy actually. So we transfer the ownership from T1 to T3. Well, it's either not a T3 but a T2 in our case because we start indexing from 0, and then what we do is we back again to T0 and move T2. And let's see what happens. Okay. Abort. And exactly we hit an assertion probably here somewhere. When we were moving an object, right? We couldn't, probably we checked whether the thread is joinable, and it was, but we still moved. So what's the problem? So we create thread 0, we create thread 1, we move the ownership from T0 to T1, then we move to T0 the ownership from a temporary thread, oh, maybe it's because this thread wasn't joined. Yeah, okay. I think maybe it's because, but it was moved, so it should be correct. Yeah, okay. I know what happened. So here we created the thread, which is a temporary variable, right? And we moved the ownership to T0. So ideally, what we should have done, we should have invoked join in order to successfully end the thread, right? But we didn't. We just overwrote it here with the contents of T2. So we never call, even though, okay, let's no, wait a second, maybe I'm completely wrong. What happens with T1? I don't understand on which thread I should call the join method. So we moved T0 to T1, then we moved from T1 to T2, then we moved from T2. Okay, so the right way of doing things will be this. Yeah, we're still abort. And I assume the problem is because, as I was trying to explain earlier, that we moved the ownership from the temporary variable to T0, but then we overwrote it here. And basically we join in this thread, the T2, but the thread that we created here is never joined. So we cannot move here. Because join method for temporal thread will never be invoked. That's how I understand it, right? That's how I understand it. But let's take a look what there also says. Is transferred to T3, again with an explicit call to std_move. Is a named object after all these moves. T1 is associated with the thread running some other function. T2 has no associated thread. Is associated with the thread running some function. Okay. The final move transfers ownership of the thread running some function. In our case, it's T3 on back to T1 where it started. But in this case, T1 already had an associated thread, which was running some other function. So std terminate is called to terminate the program. Okay, so it's just saying that, yeah, let's take a look. So I was wrong, I assume. T0 has already an ownership, right? We transfer to T2. That's so right now, like the function, the first function is running on the thread T2, and we creating a thread, assigning the first function. Then we transfer the ownership to T1. Then the first function will be executed on T1 thread, right? We create a thread with a second function, and at this point the first function will be executed on the thread T1 and the second function will be executed on the thread T0. But then we create one more thread and we default construct it, right? And then we move T1, which executes first function, to T2, and then we're trying to move T2, which executes first function, to T0, which already executes the second function, and that's why it terminates. So that's wrong. I have to do this, join and join, and that will solve the problem because I cannot really move to T0. Okay, so that's correct. I will be finishing for today because it's now like hour and 10 minutes. I didn't expect that to be that long. So yeah, thank you for watching, and talk to you later.